Hello everyone, welcome back to another video, and in this video we will be going over a few examples following section 5.6 theory. So let's get right into the examples. Here we have number 1. It says determine the measure of angle theta to the nearest degree for A and B. Okay, so let's do A first. So A, it looks like they're giving us this side length, and this angle. So we have a side-side angle type of triangle, which we know is one of our cases where we can use the sine law, either side-side angle or angle-side or angle-side angle, right? So we know we have side B, side A, but we're missing side C, and we need to find angle theta. So what do we want to do? Well, first of all, we want to calculate we can calculate for theta straight away, because we have side A opposite to angle A, which we know, and side B, which we know, opposite to angle theta. So if we use the sine law and we say that side A over sine of angle A is equal to side B over sine of angle B, or we can switch it around and say sine A over A equals sine B over B. It works both ways. And now we can just substitute our variables in, because we know A, we know angle A, we know side B, and all we're missing is angle B, which is theta, which is what they're asking us for. So if we substitute A, 20.5 over sine of angle A, which is 105 degrees, equals B, which is 15.5 over sine of the opposite angle, which is theta. And we want to isolate for theta. So we want to divide each side by, actually, before you sub in the numbers, let's just isolate for theta first. So on each side, we want to divide B by each side. So B divided by this side and B divided by this side, which is the same thing as saying B times sine B over B, right? Because if you divide by this rational, it's the same thing as multiplying by the reciprocal. These B's are going to cancel out. And this, again, B times sine A over A, right? Multiplying by the reciprocal of A over sine A, which is sine A over A. Okay, and then we get left with, this should be theta now, right? We're isolating for theta. Now we should have B sine A over A equals sine of theta. And now if we take the inverse of each side, the sine inverse of each side, sorry, sine -1 and sine -1, it's going to give us, these two are going to cancel out, so we're going to have theta equals sine -1 of B sine of A over A. Now we can substitute all our numbers in. So our side B is 15.5 centimeters. And when you're doing this, when you're subbing in the numbers, make sure everything is in the same measurement. So you can't have meters and then use centimeters over here. Make sure everything's in meters, everything's in centimeters, in degrees Celsius, not Celsius, sorry, in degrees, and not in radians and stuff like that. So let's keep going. 15.5 sine of A, which is 105 degrees, over A, which is 20.5, equals theta. And if we put all of this into our calculator, it's going to give us 15.5 times sine of 105 divided by 20.5, and sine inverse of that, it's going to give us about 47 degrees. Okay, and it says to the nearest degree, so it actually gives you 46.9 degrees, but if you round it, you get 46 or 47 degrees, which makes sense because we have an acute angle here, and that's our theta for A. Now let's move on to B, and I'll erase all that we have on the screen so we have a little more space. Okay, so moving on to B, now we have a side, and an angle. Again, same scenario. We have a side opposite to an angle and a side opposite to an angle. So again, we can simply use the same process, use the sine law to get the answer to this question. So let's say this is side A, this is side B. This is angle, I don't know why there's two F's. Let's make this the E, F. Right, so let's actually make this side E, make this side F, and make this angle E and angle F. So we're looking for theta. So we're going to say that E over sine angle E equals, I'll do it the other way since in A I did side on top. So let's do sine of the angle on top. So sine of E all over E equals sine of F all over side F. And now let's isolate for E because that's our angle theta. We know E, side length E, we know side length F, and we know angle F. So all we need to find out, or we need to isolate for is E. So let's do that. We multiply each side by E. These are going to cancel out. We're going to be left with sine of E times E sine of F all over F. Now I'll change this to theta. And now we take the sine inverse of each side. These are going to cancel out. We're going to be left with theta equals sine inverse of E sine of F all over F. Now if we plug in all our numbers, theta is going to be equal to sine inverse of E, which is 9, times sine of F, which is 38 degrees, all over F, which is 7 centimeters. If you plug this into your calculator, sine of 38 times 9 divided by 7, and sine inverse of that will give you about 52 degrees. And that's our angle theta. Moving on to question number 2, it's a word problem, and it says a building of height h, so h is here, is observed from 2 points P, which is here, and Q, which is here, that are 105 meters apart. As shown, the angles of elevation at P and Q are 40 degrees and 32 degrees respectively, which means that their angles of a line going to the top of the wall with the ground, that's the angle of elevation, and the angle it makes there is 40 degrees from angle P and 40 degrees from P and 32 degrees from Q. And it says calculate the height h to the nearest tenth of a meter. So we can tell right away that we have a right angle triangle. So we will need one more measurement from this triangle if we want to find h, because remember, if with our primary or reciprocal ratios, we have sine of an angle equals a over b. So we have 3 variables. We need at least 2 of them to solve for the third, and right now we only have the angle, so we're going to need at least one more side to solve for h. So how can we get that last side? Well, we can use the outside triangle, which I'm actually going to outline just so I can see it better. Okay, and it says that this length right here is 105 degrees, right? P and Q, which are 105 meters apart. Okay. So what do we want to do here? We actually want to work with this triangle, not that one. With this little triangle right here, which I'll actually take out of the question just so we can see it a little better. This is 105 meters, 32 degrees, which I'll put out here. And out here, this angle is 40 degrees. So we want to find, we want to find a side from this big triangle, right? Which is still a right angle triangle with the wall. And that way we can find h, because again, we have this angle right here from this red triangle that I just drew in. So if we get one more of those sides, we can calculate for h using our trig ratios. So, why did I erase that? Okay, so we have this little triangle out here. Right away, we can see that this is a 180 degrees from one side to the other. So we can actually find this angle, which we'll name theta, which will be 180 minus 40, right? Because theta plus 40 equals 180, so 180 minus 40 will equal theta, which will give us 140 degrees. So this angle will be 140 degrees. And from that, we can also find out this angle, which we'll call alpha, because remember, all the angles in a triangle add up to 180. So alpha plus theta plus 32 degrees will give us 180. So alpha would be 180 minus 32 minus theta, which we found out is 140. And that was going to give us 180 minus 140 is going to give us 40, minus 32 is going to give us 8 degrees. So this angle right here is going to give us 8 degrees. Now, if we take a look at this side, which we'll name x, we can see that this side is the hypotenuse for this red triangle that I just drew in. If we can find this hypotenuse, we can use the hypotenuse and our 32 degrees in this right angle triangle drawn in red to find our side h using sine, because we can do sine of 32 degrees equals opposite, which is h, over hypotenuse, which is x, right? This right here is x. So we want to find x. How can we find x? Well, if we take a look at our triangle out here, we have a side length and we have all three angles. And what is this? This is our angle side type of triangle that we can use sine law in. So to find x, we simply just need to say that x over sine of the angle opposite to x, which is theta, equals 105, which is the side that we know, over sine of the angle opposite to 105, which is alpha. Now we just found out alpha, we just found out theta, and we know 105, so we can just isolate for x. So if we multiply both sides by sine of theta, we get x equals 105 sine of theta all over sine of alpha. Okay, now if we substitute everything in, we get 105 sine of theta, which is 140 over sine of alpha, which is 8. And this will give us 105 times sine of 140 divided by sine of 8 will give us about 484.96 meters. Okay, now we have x, and if we actually extract this red triangle from our question, we have, this is the big red triangle that I drew, that I outlined in here. So we have 32 degrees, we have x, and we have h, which is our height, which is what we're looking for. Now we can simply say, again, like I drew in before, or like I wrote before, that sine of 32 is going to be opposite, which is h, over hypotenuse, which is x. And now, since we found x, we can isolate for h. So if we multiply both sides by x, we get that x sine of 32 degrees is going to give you h. So h is going to end up being, if we plug in x, which we found out is 484.96 times sine of 32, it's going to give us 484.96 times sine of 32. It's going to give us about, and it says to the nearest tenth of a meter. So that's going to give us 256.9, which is actually, because it's 256.987. If we round to the nearest 10, we're rounding to this decimal number, and we're supposed to round up. So if we round up and we have a 9, we are just going to make this a 7 and make this a 0. And that will be our final answer. So h is going to be 257.0 meters. And that is it for the video, guys. It was a shorter example video than usual, but these questions do tend to be somewhat long, especially the word problems. So make sure to keep practicing, guys. Thank you for watching, and I'll see you in the next video.